Hey there, I'd like to share with you a utility that I believe may very well change the way that you do API development in JavaScript and Node. First, let me start by showing you what it does. I've issued one command to npx to run the restutils-host, and in that command I'm passing in a single value, the name of the package, UUID. I'll hit enter. And there you have it. No lines of code, and we now have the commonly used UUID library hoisted into its own web API with all of its operations exposed via RESTful endpoints. Now, the one that I use most of the time is v4, so let's open another terminal window and make a call out to that function. And there you have it. We have a result from the UUID library, the v4 function, with the new UID that we asked to be created. No lines of code. It's not my library, but every function and property that exists inside of that library is now available to me on a REST endpoint. So why is this significant? Let's take a look at an application I'm currently in the process of building. So what you're looking at here is a pretty typical solution built in Node.js using a microservices pattern. We can see that it's broken up into a couple different security zones, public, private, and secure. But at the end of the day, we're looking at 20 or more APIs that each do their own little thing. The problem with this pattern is creating these libraries is the same tedious work over and over and over and over again. You've got to decide what server to use. You've got to write middleware operations. At the end of the day, this API and this API structurally are at least 85% similar. This pattern works, but it's tedious. We're constantly trying to sync our file changes from one repo to another. We have duplicated files everywhere. And most importantly, the amount of churn that has to happen to spin these up and keep them in sync bogs down any development team, whether you're a solo developer or have an entire team. The utility that I'm showing you today removes all of that. It allows anybody to write the simplest JavaScript file without any worry about what that web hosting side will ever look like, and without losing any RESTful functionality that you need in a microservice solution. So what we're looking at here is the Git repo where the project is hosted. As you can see, the example that's shown is the same one that we used a moment ago with UUID. There's another section here with a bunch of samples that we're about to look at in a moment, mainly just to show how simple your syntax really can be if you use this pattern. And then it discusses a singular coding requirement. So at the heart of this utility are a couple very simple concepts. The first concept is that every property and function inside of your library will be wrapped and exposed in an API. It'll either be an HTTP GET operation for properties or an HTTP POST operation for functions. So how does it work? Let's look at the example that's down below. In the example on your screen, you see that a member object was passed in, or more specifically, the ID to a member was passed in. You'll also see that a couple of query string parameters were passed in along with that call. For every request that comes into your function, both the body and the query string are combined into a single property bag and passed into your function. Which brings us to the singular coding requirement you see above. Your functions need to accept a single parameters object. Now you can destructure that parameters object and do as you wish, but everything on that post is going to come in, both the body and the query string, into your function. The example we're looking at here is available in the repo under samples params, but we'll take a look at that in just a moment. So let's talk about installation for a moment. As you saw at the beginning, I didn't use any installer. I called upon npx. That is the preferred method that I use. npx has enough intelligence to determine whether or not I have the utility locally. If I do have it, it'll use it. If I don't have it, it'll go and fetch it. Again, that's the preferred method from me, but if you did want to install this globally, you could install it globally. There's nothing stopping you. And as you can see here in the usage area, you essentially have three options. You can pass in the name of an NPM package that's already published. You can give it a fully qualified path to a hosted repo somewhere, or you can give it a fully qualified path to a local directory or file. Now, if you give it a path to a file, that is the entry point that will be hoisted into the API, and that is where that interrogation of your object will begin. If you give it a directory, it's going to look for package.json and determine what the main entry point is that's defined in your package.json. But in all of these scenarios, the key is that it's going to fetch the resources that it needs, it's going to interrogate your object, and it's going to present it in a web API for you to make RESTful calls to it. Scrolling down, we look at some of the parameters that are available. There's not a bunch, but they are useful. As you can see here, one of the key parameters that you might be interested in is depth. Maybe you have a very complex object and you only want to skim the surface or the first operations. So you can set the depth to something small like 1 or 2 and ensure that the utility doesn't recurse its way all the way through your entire object. You have an optional base path, which is useful in case you're sitting behind an ALB or an application load balancer. Load balancers commonly keep the route path as part of the URL when it's passed into the API. And so this gives you the opportunity to account for it. Of course, you can change the port or disable cores if you didn't want it. So that final one, shutting off the install, is useful if you're using something like npm link. If you're using npm link, obviously you don't want to overwrite those files that you have linked locally, and so you can skip the install if you need. And the last section talks about debugging. I didn't use the flag when we looked at the example a moment ago, but you can pass in the node options flag with npx, and this will give you the opportunity to step into your library just the same as you normally would, so you're not losing any functionality. All right, so let's take a look at those samples. So what we're looking at here is the launch.json file that's in VS Code. We've got a couple basic configurations here. The first one is a common attach. This is what you'd be using if you set the node debugger to listen. This is what you would use to attach to that process. We've got a couple helpers in here. And here's the first example at the top. Of course, it's Hello World. So let's go ahead and launch that one. Hello World. As you can see, it's running. Now let's look at the source code for this so we can explain what's going on. So this is the Hello World sample. Very basic. If we look back at the configuration for it, we can see that what we've done is we've called upon the command and we've passed in a single argument, the path argument, and we've given it a fully qualified path to that JavaScript file. And so if we look at that JavaScript file, all it really is a property with Hello World. Down below in the debug console, we can see that a get route was created for Hello World. It converted the name from that camel case to a snake case, something that's a bit more fitting for the web world. And now let's jump over to Postman and take a look at it. So Hello World, get property. We're going to call that Hello World path or that Hello World route with a get operation. And we get back one value listed as it's alive. All right, so that was really exciting. Let's look at the next one. Let's stop the debugger. Let's go over to the second or the next example. Next example is number 3, functions. All right, so let's get that ready. Let's start her up. And we have 2 routes, so let's figure out how that happened. Going to functions. All right, so it's the exact same example. We still have the Hello World property, but now we have a do something operation. Kind of ironic since that method actually does nothing except return a single object. Anyway, but as you can see down below in the debug console, we now have 2 operations. One is a get, one is a post. The get is that same Hello World, and then the post is do something. So let's go over here to that example, and we'll call the getter, still alive. Let's call the post. Now this post is not being sent anything in the body, it's completely empty. And now we have that response. Now if you noticed before, we received a value because we returned a primitive. And here we returned a result because we returned a complex object. All right, example number 4. Go over here to 4, child objects. So child objects is under samples, nested, and then index. So another path directly out to that file. So it's under nested. Okay. So in this example, we have 2 files. We have the index file with the same hello world and do something, but now we have this additional object that we brought into this additional file. It's called helpers, and it's exposed as the property helpers. And what's inside of that? We have 2 functions. Again, these functions both receive a single parameter, and they both do something a little bit different. So let's give it a shot. Let's go over here to child objects. Let's run that. We still have those first 2 operations from that parent level object, but this helpers object has 2 other functions in it, and so that route was created in the operations exposed as posts. So let's go over to Postman. under child objects, let's call the first one. We're going to be passing in A and B, which is 10 and 12. As we can see, that's going to do a basic, some basic addition. We'll hit send, and we have the sum. Why do we have sum? Because it returned a complex object here, and sum was the property that was sent back. Of course, if we go to subtract, we have the same two properties, and we get a -10 because it's subtraction. All right, so what's next on deck? I promise these get better. All right, so async. Okay, so if you notice in those previous examples, they were all just standard functions, right? But the question is, say, what happens if we're calling an upstream service, right? So under the samples async, we have exactly that. We have the hello world property, and we also have this upstream object. Now, upstream contains a call to an upstream server. Again, this is going to be rejected with a simulated network error. And then we have this getSum function, right? And so that getSum function is an async operation. It's going to echo out to the console, a little bit of debug. It's going to make a call to this bogus server name, and obviously it's going to fail. It's then going to return this final statement indicating that it reached the end. So let's go here to async. Let's run that. So again, because we have this getSum object inside of upstream.js, we have getSum and upstream. So let's go back to Postman, go into async, and let's call getSum. Small delay there. I don't know if you saw that, but there was a 500 millisecond timeout. And of course, we have that response upstream failure as expected. So what happened? So if we look back at the debug console, these three statements on the end are pretty important, right? So we see that the string here was echoed to the console for the start. We then show that it waited and echoed the response from the failure, and then it finally gave the end. If it didn't await in an async await, and I'm sure that you guys have run into this in the past, what you would end up seeing is you'd see the start, the end, and then most likely the failure at the end. So the fact that we see these three down here in the proper sequence, we know that the async worked successfully. All right, so what's on deck next? Deep nesting. All right, so this is where it starts getting useful. Again, not everything you create is going to be a simple JavaScript object. You may have a complex library with hundreds and hundreds and hundreds of operations, and you're not going to have those all off the root. So let's go in here and look at deep nesting and look at the index file. All right, so we have the do something operation. We have the helpers. Again, helpers has a property and another object, more helpers. More helpers has a property, which is an array, and another object, even more, and even more has some basic math in there. So let's go ahead and launch that one. All right, so again, I think you're getting the point here. We have the routes being built based on the hierarchy of the object. And if we kick over to Postman, really doesn't matter how complex the object is, they're going to function as expected. So now you ask yourself, what happens if I don't want it to nest that deep or recurse my object that deep? How do I prevent that from happening? So that is why this example here exists, called excessive nesting. I'm just going to launch it. I'm not going to drag you through reading it. But essentially, we have this never-ending list of all these methods and operations. And if we go into excessive nesting, we can see that way down here, we have the same functionality. The only difference is those routes were built dynamically based on the complex object that exists there. Feel free to look at that deep nesting. But really what I wanted to show you more than anything is this bad boy. So it's the exact same file. This is the excessive nesting sample that we just looked at a moment ago. But we have added to it, we've added this depth argument of 2, right? So there's nothing really at that level 2. But what I wanted to show you is the fact that you're not really at the mercy of the entire object. If you want to stay at the top level and not go any deeper, specify a depth with, like I said, a 1 or 2, and you'll stay at that root level or just beneath it. So let's launch that one. And again, as you can see here, we have hello world, and we stopped at level 2 because we have that depth property being passed in. All right, so now's when the fun begins. Up until now, we've been looking at individual files. So all these paths point to a direct index file. That is the entry point of your API. In this next example, we're going to look at what happens when we point it to a directory. And so we have an example here called package.json. And so in this sample, we have a simple index.js again, but this time we have package.json. And package.json is telling us that it's going to need that same UUID library that we used in the beginning. It has given us an entry point of index.js off the root. And as you can see, it has not been installed. So this is just the package.json in the index file. So let's go over here to local package. Let's hit the go button. And it is now running. So let's look back at the example, and as we can see, we now have the node modules folder. So what has essentially happened is the utility has gone out, has seen that you haven't done an install of this, and because we haven't told it not to install, it has proceeded with the installation. It then looked at your package.json, found the entry point, and started there. And so we now have this new UID value here, which calls that version 4 function, and we also have this empty field here. Now, the reason why I'm pointing out empty here is because I wanted to show the name differences. Now, I use constants a lot inside of my files. I don't like magic strings. And whenever I'm creating one, I usually make it all caps. And so I've continued that pattern forward in that when the route is created, it will still use that same capitalized name without destroying it. So essentially what you create in your JavaScript file is going to be echoed in those routes. So let's give it a shot real quick. Let's go over here to local package. Let's call upon that empty UID operation. So as you can see in this path up here, it is /empty all uppercase, and we're returning a single constant, that value that we saw here at the top, which is basically a bunch of zeros. And then of course we can call the new UID operation. That is the name of our function. And that function is in turn calling the UID package that was downloaded from npm. All right, so next on deck, what do we have here? Number 10 is skip dependencies. All right, so I'm going to go ahead and delete that node modules directory because I want to show you that you can skip this. Again, if you're using npm link or something, this is where that comes in helpful. You may not want to blow away that node modules file. So this will fail because we're not installing the dependencies, but we're going to let it run anyway to show. Let's close the previous running sample. There we go. And so essentially what we see here at the bottom, we see a stack trace cannot find module UID. And the reason being is because the install never took place. So nothing special there, but again, I wanted to show you that you can skip the install if you needed to. Number 11, npm. Okay, so you've already seen this demo once, might as well run it again just for the heck of it since it's there. But what all this is really doing is it's pulling in UUID as the package to hoist into the API. So same kind of animal, we're going to hit go. The reason why I'm showing this is because I wanted to show you where the files are stored. In this instance, we have given it UID and it needs a working space for those files to exist. So down here, you see this work directory was created. UID and latest is really what that path is. This is what we asked it to pull down. The package is stored here. If we run it again, it's going to pull from this area. We don't have to fetch it and install it multiple times. All right, we'll stop that one. Nothing really impressive. Number 12, get repos. Okay, so this is that third scenario, right? So far we've looked at giving it a path to a file. We've looked at giving it a path to a folder with a package.json in it. We've looked at giving it just the name of a package that's published on the interwebs. And now we're going to look at what happens when we give it an actual get repo or a path to a repo. So in this case, we're going to pull in, it's another utility that I wrote. There's nothing in here that's going to work well inside of an API, but I wanted to show you the success in pulling down a get repo that is not stored in this project. So let's go ahead and run that. Okay. I'm kind of glad this happened. So I can't tell you why that takes place. So you saw that 128 error that took place. It happens. I've done some searching on the interwebs, and it indicates, so there's some Git libraries out there that basically say if this happens, there's something wrong with your build environment. Clean it up. Now, as you can see here, it recovered and it continued forward. If you do see this failed status with 128, when you're calling from a get repo, just run it again. I don't have a good answer as to why it's happening. And once I have that, I will definitely account for it. But if it happens, run it again and you won't have that problem again. As a matter of fact, let me go ahead and kill that off and let me start it again and clear the terminal. Let's run it again. Yeah, and no operation or no failure. So it has something to do with get and the way get's calling the repo. But like I said, it is very fleeting, doesn't happen all the time. And if you run it again, it resolves itself. In my opinion, there's probably some async process that they're not allowing to finish before they report back that it's finished. All right, so here we have that massive utility that I created called Cleaner Node hoisted into an API. And you could use many of these operations. There's quite a bit of them that will receive a single value and do something with it. You know, for example, there's a hash string operation here that'll take any string and give you back an MD5. There's some other stuff here where you can get a block date or validate some emails and that type of thing. So let's see what we got here in Postman. Get code. Okay, so in this example here, what I'm doing is calling some constants that I have in the library. It's under constant HTTP status codes and then non-authoritative information. There's no way I would ever remember what that numeric value is, 203. Okay, we know what a 203 is, I just know that name. But anyway, so what I've essentially done is I've now called into that library and pulled back that getter. New UID is similar to the one we just looked at. I use UIDs a lot and keep them as 32 character strings. And so this is a utility that I use for that type of operation. Count values, yeah, another useful one. It's a basic array function so that I can pass in either garbage or a valid array and not have to worry about an exception being thrown. And this will return back the count of 4 because I gave it an array of 4 items. So again, what we're looking at here more than anything is not necessarily my utility. It doesn't matter whose utility it is, but you know, this was essentially a repo that's sitting on the interwebs, and it pulled it down, sucked it in, and hoisted it in front of a web API. What we're looking at here in that same work directory, you see this hash. That hash is basically a calculated path so that we don't have to worry about case sensitivity and such. But the long and short of it is all of your files will be pulled down to this work area, whether you're pulling from node whether you're pulling from NPM or you're pulling from a get repo. Example 13 is a database example. Nothing really all that magical here. You know, we've got another kind of NPM project. In this case, we're calling out to Mongo. This is, I guess, following a bit of a repository pattern for getting items. So if we run the database example, took a little bit of time there because it had to pull down the resources that it needed. If we look at what that meant, it was pulling down, well, MongoDB, that does take a little bit of time, but it pulled down the client library. It pulled in the operations it needed to. And again, since these items here, this URI, the client, the database, the collection name, since all these are not exported for the module, then they're not picked up. So if we go over here to Postman and go to the database example, we have the ability to create an object. Now we can get items. There's some in the database. We can find a specific item, your widget. If we wanted to continue to add values, first name Joe, last name Smith, send that in. Let's do get items. And there we have it. I think that might have been all the examples. There's another one here called params. Let's see what that does. I don't remember creating that one. I know why I created this. So a very basic example. The reason why I created this was really to show that combination. This is the one that we looked at on the GitHub repo. So this example here. So let's start it real quick so you can see it running live. So we have hello world and with params. And so again, all with params does is it takes that property and it sends it back. And I guess this is interesting to look at because what you're going to see in the example is I'm going to send in an object with just a single property on it, but I'm also going to send in some query string parameters. And as you can see here, we're only accepting one thing. We're accepting the data object, if you will. So let's go over here to, I didn't create it. So let's create it now. Let's take this post, let's duplicate it. Let's change the name with params. We know that this is the path, so let's copy that. Post with params. And again, we wanted to show some properties. So let's do name equal Joe and car equal Corvette. And then we need to give it a body. The body will be member ID 1234, and we'll send that away. So what you're looking at, again, if we look back at that example, we see that we're only accepting a single data object and we're sending it back immediately. But what's key here is that we passed in two different values, name and car, as well as the original object. And so this is just showing what happens to that request as it comes in. Both the query string as well as the body are going to be combined and passed in as a single data object here for you to be able to examine, tear apart, destructure, do with it as you wish. So that's really about it. Again, I think this is useful because it allows you to start with some very, very primitive JavaScript. As you can see in these samples that we looked at, there is nothing specific to HTTP, HTTPS, or Express, or anything of the sort inside of these samples. They're just basic JavaScript libraries. It doesn't matter whether or not you're writing them locally in your machine or you've published them on the web. You issue one command and that simple JavaScript library, that simple node package gets pulled down, gets installed, and is presented to you by way of an API that you can then tap into and fold into the rest of your microservice structure. So my contact information is at the bottom of this repo. If you run into any snags whatsoever, if you have suggestions for improvements, if you think the thing totally sucks, reach out, let me know. How can I improve this? Let me know what your thoughts are. I would love that feedback. And if I can improve it in some way to make your life a little bit better, I'll be happy to do that. Thanks a bunch and have a great day.